Here we have a familiar situation. A ball goes at a horizontal velocity 15 meters per second from the top of some kind of a cliff or platform or something, and follows its parabolic arc for 20 meters down to the ground below. The ground is supposed to be level. I just didn't do a very good job of drawing a straight line here. The question is, what's our final velocity? What's the vector velocity? That means the magnitude and angle of the velocity at the instant of impact down here. And we represent that by a vector. Really, this vector should be a little longer compared to this one, but we're actually not all that far off here. Okay? So we're going to do this, we're going to do this simply by analyzing the motion. We know that we can find the magnitude and angle of this vector velocity if we can find excuse me, both the final x and final y velocities, because of course any vector is the sum, or is the resultant of its x and y components, any vector in an xy coordinate system, and we'll use a traditional xy coordinate system here. So what's VFX? Excuse me again. Our hypothesis, our observation is, or our assumption for a projectile, our first assumption is that there's no air resistance, so that the x velocity remains constant. Of course, this isn't really true, but it's the assumption that we're going to make here. So the x velocity is 15 meters per second, so the final x velocity is going to be 15 meters per second. So we've got that very easily. To find our final y velocity, well, the ball starts out at a horizontal, means that initial y velocity is 0. So we're dropping 20 meters from an initial velocity of 0. Well, we can write this out more formally. The final x velocity is equal to the initial, which is 15 meters per second. The final y velocity we obtained from the idea that the initial y velocity is 0, the change in position is negative 20 meters, and the y acceleration is negative 9.8 meters per second squared. We want to find the final velocity, so we're going to use this equation of motion. We can't reason this one out directly, so we go ahead and use the equation of motion, and we easily obtain a velocity of plus or minus 19.8 meters per second. If the upward direction is positive, which we've implicitly assumed since the acceleration was designated as negative, as was the displacement, then the final y velocity will be in the same direction as the displacement and acceleration, or downward, and that'll be negative 19.8 meters per second. Now to find the magnitude and angle of the final velocity, it's no problem to first draw a sketch. We have an x component of 15 meters per second and a y component of negative 19.8 meters per second. We use the Pythagorean theorem to get the magnitude of the final velocity, which is around 25 meters per second, and the angle with the positive x-axis, which we get as negative 53 degrees, and we might well change that to an angle between 0 and 360, which would be 307 degrees, but I haven't written that down here.